Welcome back. We will be continuing the prerequisites chapter section 1. This is part 2, and in this video we will talk about sets. Sets are a very fundamental part of mathematics, and a set, by definition, is simply a collection of things. This is a very vague definition, and part of the reason is because the set is such a fundamental object, it's a little bit hard to describe. So one analogy is that a set is kind of like a bucket, and the bucket can have some things in it which we call elements. So for example, I could make a set that has the numbers 1, 2, and 3 in it. This is a perfect example of a set. We can have more things in a set. We can have a set that contains -13, -2, 0, 6, and 107. Sets don't have to just have numbers in them. So for instance, I could have a set that has a square and a triangle in it. And what you'll notice is that with each of these sets, I've listed all of the elements in the set. We don't have to list all of them as long as the pattern is clear. So for example, I could say I have a set that contains 1, 2, 3, have some ellipses, and then say 9, 10. Here it's clear what the pattern is. This should just contain every counting number between 1 and 10. But again, this is all called the roster method for describing a set, because what we're really doing is we just have a list. We don't have to just have a list. We could simply describe the elements in the set as well. So I'll use x to represent an unknown here, and I'll take the set of all x, where x is going to be any number that is less than 10. And when we read the set, the way that we would read this out loud is the set of x such that x is less than 10. So this is a fairly clear set. So for instance, 2 is less than 10, so 2 is inside of the set. But 100 is not less than 10, so 100 is not in this set. So we have different ways of describing sets. And what can we do with sets? So there are two basic operations that we'll talk about, being the intersection and the union. So when we take the intersection of two sets, A and B, we write A intersect B. This sort of funny upside down U shape denotes intersection. And what you get when you take the intersection of two sets is another set, and it's the set where A and B overlap. It's the elements that are in both A and B. So for instance, if one set, if our first set A is the numbers 1, 2, and 3, and our second set B is going to be the numbers, will be the set containing the numbers 1, 3, and 5, A intersect B is going to be, again, a set, and it will contain all of the elements that are in both A and B. Well, we can pretty easily see that this is just going to be the numbers 1 and 3. We see that 1 is both in A and B, 3 is both in A and B, but if we look at 2, 2 is only in A, it's not in B, and 5 is in B, but it's not in A. So this is the intersection. A nice way to draw the intersection of two sets, if we have a set A and a set B, the intersection is just the overlap. So this is A intersect B. Okay. So sort of opposite of the intersection is going to be the union. And the union of two sets, A and B, which we will write as A union B, and we'll use this sort of U-shaped character, is going to be the set of all of the elements in both A and in B. So we're taking A and B and we're combining it into one big bucket, using our analogy from before. So let me do an example to make sure that this is clear. So again, let's do the same example with the same sets. So we'll have A being the set containing 1, 2, and 3. and we'll have B being the set containing 1, 3, and 5. And when we take the union, A union B, I want to combine these sets into one. So I'm going to take every element from both of them and write them in one set. So 1 is in A, so we put it in the union. 2 is in A, so we put that in the union. 3 is in A, so we put that in the union. We already wrote 1 down, we already wrote 3 down, but we don't have 5 yet. So we'll throw 5 in as well. And that's the union. The union is made up of all the elements in A or in B, or in both. And again, there's a nice picture that we can draw here. If we have A being one set and B being another set, maybe they overlap a little bit, but the union is going to be everything that's just in A, everything that's just in B, and everything in both. So this is going to be A union B. So to draw this picture with our two sets, A, we had the numbers 1, 2, and 3. And with B, we had the numbers 1, 3, and 5. So we can see that 1 and 3 are in the intersection because they're in both. 2 is only in A, and 5 is only in B. One thing to notice here is that I didn't list 1 twice inside of the union, even though it's in both A and B. We simply say that 1 is going to be inside of this union, and we just write it once. The idea here is that either an element is going to be in a set or it's not in a set. It can't be in a set twice or fewer than none. It's either in there or it's not. So we just list it once. And I'll continue in the next video.